Alright, hello and welcome back to my real-time strategy in Unity tutorial. Today we're going to be covering a couple of pathfinding optimizations and improvements, because if you were watching last time I showed at the end of the video, sorry, that I'll just maximize that. Basically that if we were to create a sufficiently long enough path that, say, encompassed one end of the grid to the other, there was quite a large hang while the game tried to calculate the path. Well, the game calculated the path, which, as you could, well, obviously isn't acceptable to have in the game. So we have to find a way around that. But also, I've implemented a system to try and reduce the overall number of nodes without compromising on the game quality or mechanics or whatever. So that is why you'll see two different types of squares, which basically is just a visual representation of how I've tried to make the pathfinding more efficient by having less nodes in the grid overall, and I will explain how that works. It's pretty simple. But for now, I'll just show you that, yes, if I right-click here, you can see that we're not lagging, it's not holding anymore, and it's trying to calculate the path for the archer. So if I just show you, basically it's out of range because I think that's trying to move, but it's not got a path, so I'll have to fix that. But it'll wait for a path while we've got, you can see it's waiting for the path, and once it's found it, actually I'll just go into the scene view. We go over to here. Once that has stopped, so it'll have found the path. It doesn't, yeah, see, there he goes. So he's been able to find that really long path that was quite expensive to calculate, but without holding up the game, and this was done through multi-threading. Okay, so some quick theory on threads and stuff like that. So basically, Unity has two threads. One is the Unity main thread, which runs basically stuff like update every frame of the game, and I believe it also has a second thread for controlling physics in the game. Don't quote me on that, but I believe so. And basically, what we were doing before when we didn't have threading is that we'd call for a particularly long path, and while it was getting the path, we couldn't do anything in this section here because it had to wait for the path to run the next frame. So this meant no updates could be run, stuff like that. And basically, so it gave the appearance of the game freezing up. But thanks to using threading, we can now, on this call, we can say, all right, I want to offload this job to another part of the processor, which means that core, like core or whatever, will do the pathfinding on the data, on the pathfinding grid, and it leaves the Unity main thread free to do other processing, like combat, building, shorter paths, whatever. And then once this thread is done, it can then return the value of the path to the main thread, to whatever unit was wanting it, and that unit will go over the path. It doesn't particularly make the pathfinding any quicker, but it stops it hanging, which is like a 90% improvement. So yeah. Is there anything else? There are a couple of rules that you have to keep in mind when you are using threading in Unity, though. The first is you can't use Unity specific methods, so accessing like .gameObject, .transform, stuff like that. You can't use them. It doesn't allow that. Yeah. You can use stuff like raw data types, like vector freeze and that, because they're not exclusive to Unity. I believe you can use your own classes as long as they're not using any mono behaviors. I think that is the thing that Unity doesn't let you use in other threads other than the main thread. And yeah. And the second is you've got to be, it's not impossible, but you've got to be careful about when you're editing data that's in the main thread. You've got to ensure mutual exclusion, which is that only one thread can edit data, one bit of data at any one time, because you don't want to be saying, like, in the main thread, all right, a unit is at 0, 0, and then at the pathfinding thread saying, "Oh no, it's at 100, 100," because then it'll just look bad and lead to all sorts of nastiness. So yeah, so you can edit data. You can use locks, and we do use one in the code, which I got from a Unity Answers question, which I'll be sure to show you, just because crediting people's work and that. Yeah. So you want to be careful, and if you can, well, stick to it. Just use threading for jobs that don't require editing data and don't use Unity methods. So we've had to manipulate the Pathfinder a bit to fit those rules, but it works. Now onto the code. Okay, so to use threading with our pathfinding, we basically created a new class which sort of acts as a controller for the thread. So this sort of like it starts a thread, waits for the thread to find the path, and then will return whatever value was returned from the thread. So it sort of controls it, and then nothing else has to touch it, basically. So we've got, and this is based off code from here on the Unity forums by Bunny83, which I was posted a fairly long time ago, but it works. So thank you for that. I've edited it to basically work with the pathfinding and stuff. So yeah. So basically, first off, we have lock, which is used to ensure like mutual exclusion and stop other things editing the is done value. Sorry, while this script or the thread is editing it. Yeah. So I've got bool is done, which basically says, is the thread done executing, do we have a path? We've got two vector threes, position to go to and the position from. They're pretty obvious. They're just start and finish points of the location. We have a thread, my thread, basically so we can reference it and work out if it's done or not and stuff like that, and start it. We've got a list of vector threes, which is the final path. Again, stuff like lists, vector threes, you're all right to use in your threads because they're not Unity specific, they're part of C# and whatnot. And we've got a unit wanting path reference, so that is just basically a reference to the unit that wanted the path in the first place, so we can return it when the path is done. Okay, so our first method is initialize. It basically just sets all the values that we need for creating a path. So that needs to be done first. I've got a public boolean is done, which, as you can see, is a bit different to how I usually write it, but because it's from the Unity answer page. But basically, we've got a get value, which basically just returns is done, but we'll get the value of is done, and well, basically it gets a temporary bool called TMP. It locks my lock, so nothing can sort of like, I believe it's nothing can run in this bit while this lock is in place. So it just sets TMP to is done. So is done can't be changed while this lock is in place. So I mean, it'd be like a negligible amount of time, but that's basically what it does. So it can't like change instantly or something. And then it just returns it. And the setter is basically a lock again. So we can't change is done from anywhere else, and we set is done to value. Yeah. We have a start method, which is basically just starts the thread with our run method. And when you're passing in methods to be run on a separate thread, you can't pass in arguments, basically. So that's why we needed the this class, basically, to store the position to go to and the position from before we start the thread. So we can't just run the thread from the unit movement script because we need to have somewhere to reference the values from. We've got a get path, which basically just calls the Pathfinder methods. You'll see that this one has an underscore before it, which does mean something, but I'll get to that later because that's part of the node optimization that I did. I've got a public boolean update, which basically is, it runs every frame, but it checks if we're done, and if it is done, it will call the unfinished and return true. Otherwise, it returns false. So basically, this is like saying, if it's done, we're going to call this and return true. So we'll know, all right, we've got the path, we're done, it's cool. And if not, it'll return false. So say, okay, we'll check again next frame to see if the thread is done and the path has been got. We've got a private void run. Basically, this is just what is run in the thread. It calls get path, and when that path has been got, it'll finish this method call. So it'll then be able to say is done as true. And on finish, we reverse the path that we got because for some reason it was returning it backwards. I'm not sure why. And we finally set the unit wanting path to move to the location by calling the move to location method, which is a new overload that I made, I think. So I will show you that. Okay. So I've made a couple of changes to the unit movement script to use this new threaded pathfinding. Basically, when move to location is called, it basically creates a new threaded pathfinder and stores it under TP. It then initializes it with the position we want to go to, the unit's position, and the unit movement script, so it has somewhere to pass the path back to. Then calls the start method, which, as we showed before, starts the thread, like stuff. It then sets waiting to path for true. Now, we've done quite a big revamp of the update function here. So if we are waiting for a path, and if threaded pathfind is not equal to null, basically check in every frame if dp.update is if it's true. So if it is true, on this case we said if it is true, then the path is finished and it'll set the unit's path to it. And yeah, so if it is true, then it debugs over. It logs that we got the path and then sets it to null. So yeah, because we don't need it anymore. And as you can see here, it just debugs it now. Yeah. So when the path is done, we basically call this method, which is an overload of a move to location, which takes a list of vector frees. Basically, it sets path count as a 0 and sets current path to the path that's passed in, and says we're moving. So are we moving is now true, and waiting for path is false. So we said, all right, we've got the path now. We're not waiting anymore. We can do it. And if the current path is 0 length, so if for some reason we got passed in a path that was horrible and went wrong somewhere, we just remove the action because we don't need to do it anymore. So yeah. So if we are moving, then we just move along the path. And again, I think this is the same as when we actually made the unit movement script way back. Basically, just got two positions. Got the target pars and the unit pars as a vector 2, and we're basically just checking the distance between that and iterating through the list of points that make up the path. And once we reach the end of it, we set are we moving to false because we've reached the end of the fucking path. I've also added as a reference for some of the action scripts the get final position, which basically returns the last element in the current path. So yeah, that's the thing. Yeah. We also did make a couple of changes to the Tile Masterclass, I believe, which is it has a position in world, which is basically just a vector free that stores the location in the world. Because we're in the Pathfind script, we can't use Unity. Unity methods like say game objects dot transform dot game object. We couldn't do like that, transform dot game object in the thread because it'll just error out and say, all right, you can only do this in the Unity main thread. And this vector free for Pleasant World is set when we declare the grid coordinates. It basically just gets the position because these grid coordinates will be set when we're generating the level. So that's all good. And yeah. And then we just got a separate method, I believe, here somewhere. basically returns it. Oh, actually, it's just public, so we can just say, no, it's not public. Where is it? Am I seeing things? Set parent, get pos in world here. Sorry. And you will see that there's a my node, but we'll get onto that because that is part of the what was it? The node optimization, which I'm doing as a separate part. So yeah. Okay, so first I'll just show you the Pathfind changes we made. Because yeah, sorry, never mind. Where is it? So as you can see, when basically the main change we made was when we are converting between getting the position in the world for the tile, we can't use retval.add_tile.gameObject.position anymore because this will be run in the separate thread to the Unity main thread. So what we do instead is we retval.add tile.getPosInWorld. It gives literally the same effect, but it doesn't use any of the Unity things like gameObject or transform. So it's okay to have in a separate thread. And that's a bit of it. Is there anything else? Let's check my script. Yeah, that's pretty much it. Now on to the node optimization. Okay, so now we're on to the second part of the improvements that Pathfinder made, which is the node optimization, which basically you'll see by this handy little visualization I made, which was basically just a sprite render on a sprite, but whatever. You can see that there are a selection, basically small squares and large squares. Now, the large squares are basically where I've found in the grid where there are locations of 4 tiles that are identical in a 2x2 grid. We've basically just sort of combined them into one node, which is basically the dot in the center. But if we don't have that, so say we got one of the tiles is different, like here. So we've got 3 unwalkable water tiles and 1 walkable grass tile. It just creates 4 separate nodes. So yeah, that's pretty much the same. It does that for the other types. So you can see the trees here, rocky, whatever. And I think I did a. I'm trying to find it because I had a. Yeah. So by doing this, of the I believe it was 60. It's 250 by 250. Hold on, let me do some maths. 250 is something like 62,500. So of the 62,500 original nodes, we have saved 38,508. So, you know, there's still a lot of nodes there, but I'd say that that's quite a good saving. All right, and let's see how we did this first. We're just basically going to look at the node first, because that's quite simple. Basically what it is I've ripped all the pathfinding information, so G and H cost. We don't actually need to type, but so I can go. And the position in world for the pathfinding nodes, which was this information, this bit, the top bit here, all in the tilemask class originally. So you'll see it's pretty much identical, but with a couple of changes. One is a my tiles. So this is basically a list of the tiles that encompass this pathfinding node and is used to when we're working out like what if the tile node is walkable or not and stuff. Because we're still going to be using the tile system to place buildings and whatnot. So there, and we also have to have a list of neighbors now, which will be basically adjacent nodes to this node, which are walkable. The reason we do this is because we're not storing the nodes in a 2D array anymore, because as you see with, did I leave it up? Yep. It's not like completely even for the X and Y axes, because say we could have one node taking up 2 rows, and then like, you know, single nodes and whatnot. So we can't store them in a 2D array anymore. So instead we have to work out what the neighbors are via manually, basically. A couple of different changes. One, we have an update node, which basically goes through all the tiles that make up this node and counts if they are walkable or not. And if there are more walkable tiles than more unwalkable tiles, we set the node to be walkable, else we set it to be unwalkable. And we also have a method of checking if this is a valid location for a building. Basically, we go through all the nodes in the neighbors and we check if they are all walkable. So once we return true, otherwise we return false. And what this aims to do is basically, like with the original tile mask class sort of building placement, we want to ensure that there is a path round the building once we've placed it, so units don't get trapped or stuck or whatever. And that's it. Okay, so now we're just going to be looking at actually how it's done. So basically, we get the grid of tiles from the grid generator script, and we loop through it in increments of 2, because we are taking 2x2 samples of the grid. And here we store it. So this one will be the bottom left, bottom right, top left, top right, I believe. And we basically go through these, we add them to a list just for ease of checking, and we wanted to see if they are all the same type. So for each of the tiles, if their type equals the type of the first element of a list, so the first tile, so tiles X and Y, then, or if it doesn't, sorry, we set all the same types to false. So say if you had 3 water and 1 grass tile, that'd be false, but if you had 4 grass tiles, it'd be true. So if we have all the same, so if the tiles are not all the same type, sorry, basically what we do is we instantiate 4 nodes, basically at the position of each of the tiles, and we set the z to -2. Then from these game objects that we just created, we get the Pathfind node, which is the separate script we just looked at. We then set the position in the world for the Pathfinding node for each of them. We then set the node to walkable based on if the tile is walkable or not. We then add the tile mask class to the node's list of tiles. So this list here, so we can work out like if it's walkable or not from there. And finally, for each of the tile mask class, we added a reference to the my node, which is basically the node that this tile is a part of. So yeah, let me do that. And if all the tiles are the same, we basically do a similar thing, but instead of doing it for each tile in the grid, sorry, we just do the one. So we get the position of the, I believe that's the bottom left, bottom right, sorry, bottom right tile, and we take 0.5 from the x-axis and add 0.5 to the y. So this basically gives us a position that is in the intersection of these 4 tiles, so the middle basically. And then we create a new node here. And we set the scale to be 2, so it's a 2x2 grid. So we can basically just show that it's how it looks and where the point for the node will be. Then for this pathfinding node, we add all 4 tiles to the my tiles list. And we add these nodes to the pathfinding list of nodes, which is actually the pathfind class. So we do this for the if they're not the same type as well. This is basically just a list of nodes, because I've basically created separate methods for using the nodes and using the tiles for pathfinding, just for sort of simplicity, and because we still use bits and pieces of this, I believe. So I just wanted to keep it all there, but from now on we are using this kind of this node-based pathfinding as your we saw with the unit movement, because it's the threaded pathfinding where we call underscore get path, and underscore refers to the versions that use nodes. So yeah, so we add that to the list of nodes. We set its position in the world to the position we spawned it at, and we set the node to walkable based on whether the first tile is walkable. And then we set the individual tiles nodes to be part of P, or the pathfinding node we just created. So after these 2 for loops are done, we do another one where we go through each of the grid generators. We go through every tile in the grid. Sorry, just get a yawn here. Basically, what we do is we get the tile at the X and Y coordinate, because we're just going through one at a time now. And we get that tile's neighbours using the grid generator.getTileNeighbours of that tile. And then for each of the neighbours, we check if that node's my node contains the list of neighbours. So basically, we're checking the tile master class, we're getting the node it's a part of, so the pathfinding node it's a part of, sorry. We're checking the neighbours of that node, and if that list of neighbours contains the original node we were looking at from the tile we got here, if that's not in it, or if vice versa, so for the original node, if for the original tile, sorry, if that tile's node's neighbours doesn't contain the node of the tile we're looking at now, then we add them to each other. So that basically says that the 2 nodes are adjacent to each other. So we add them, but we want to make sure that we don't have the words aren't coming. That's not good. We don't want to add like the node to itself, if that makes sense, because if we have like a 4, if we have a node, 4 tiles that have been combined to one node, some of them will have the same node. So we want to check that it's not, the 2 nodes aren't the same node, basically. And yeah, that is that bit. Now I'll just show you the bits of pathfinding that have changed. So basically, this is a doppelganger of the above code, except it has a few changes. One is it adds the end position to the path that it gets, so once the path has been found out and whatnot. So just so it goes to like, it gets closer to the place where the user clicked. We also set those positions to -2, just so they're on the same z-axis as the unit. Because remember, it's -2, because as you decrease on the z-axis, you get closer to the camera, which is at -10. Again, I believe it's this one that's actually called. So yeah, and then we got get path, which is basically identical, but again, basically for all this code below here, it's just a copy and paste again, like I said. But we've Control F, and you can use this. So we replaced tile master class with pathfind node here, but we don't want to do that again because it'll replace all the rest of it. And yeah, so here, go through all of it. There was one, and also there's like small little syntactical differences, because I changed the names of the methods to say is node walkable rather than is tile walkable. I'll just show you. Like there is node walkable, set node walkable. Yeah, that's that sort of thing. Yeah. Where is convert to vector path again, because we're using it in a thread. We have to use get pos in world rather than .transform .position. And I believe the get node by location basically grabs. It will grab the tile master class at the X and Y coordinates of the grid, basically, and that is trying to. Sorry, what am I on about? Basically, gets the tile at the X and Y provided, like we did before, But this time it just returns the node, and it returns the node if the tile is walkable. Otherwise, it gets the neighboring nodes to that pathfinding node, and it will check if any of the neighbors are true, and then it will return that node. So basically, if the user clicks on somewhere that isn't a walkable node, but there is one next to it, it will just return that, just as like a sort of usability thing, yeah, so you get the idea. And again, for get distance, since we don't have, we're not storing the nodes in a 2D array anymore, we have to use the get position in the world to estimate the distance between the nodes. So we just, instead of using get grid coords, we're using get pos in world. And that's that. Okay, so one other thing I added was basically, one thing I noticed was that you could place buildings over units, which I wanted to stop because that's a bad thing. So what I've done is added a cursor collision check to the building placement cursor, so now we can't place it over there, but as you can see, we can place it here. I'll just show you how it makes nodes unwalkable. Basically, every time like a tile is set unwalkable, it'll call its check the node check. So that method is here. Where? So every time a tile's walkability is changed, and if my node is not equal to null, it sets my node.update node, which is here. So basically, like I said, it goes through checking how many tiles are walkable or unwalkable and changes the node's walkability based on that. And yeah. And the cursor collision check is here. Basically, it has a trigger, a box collider that's a trigger, and a rigid body. And what that does is, it on trigger enter, if it collides with a unit, it says over unit is false when it should be true. And I probably shouldn't change this while the game is running. But it worked the same anyway, so it should be fine. On trigger stay, it sets true, and on trigger exit, over unit is false. So basically, over unit is another condition, which is used by the selection manager. If I can create buildings for left mouse click. Oh, sorry, let's get yawn. So yeah, it uses to change the building placement cursor's sprite. We now use this set sprite method, which basically sets the sprite and changes the size of the collider, which detects if a unit is in the way. So that's quite nice. And basically, we check if we're not over a unit, and if we're not pathfinding blocked on a building. So yeah, this is that, which is a new method which I've made, which is down here somewhere. So building pathfind block. Basically, it goes through each of the tiles selected and checks if that tile's node is a valid location for a building, which we did before. So which is basically this method, which goes through all the neighboring nodes of the node that we've called it on and checks if it's walkable. If it is walkable, it returns. If they're all walkable, it returns true. Otherwise, it returns false and says, "Nah, you can't build it." It might block something off. Yeah, so that check is done twice. Once when deciding the color of the sprite renderer, and once when you've placed the building. Okay, so another change we made for the selection manager is how we get multiple tiles for placing buildings. Is basically, instead of using a raycast to get the tile at the mouse, we just basically get the tile using a conversion of the screen coordinates of the mouse to world coordinates. The reason we do this is basically because if we're trying to place a building, then the raycast is going to hit the thingy, the collider on the cursor. so we don't want to do that. So basically, instead of using selection raycast ref tile at mouse point, we just basically get in the screen the position of the mouse in the world, using that to get a tile out of the 2D grid of tiles, and then getting the tile master class and working out if the grid of the size specified around the tile that we found is valid for buildings, or if all the tiles are walkable. So yeah, that's about it. There were a few changes to the actions for units to basically, if they were checking for, if we're checking that are we moving is false and waiting for path is false. So basically, we have to do both checks to make sure that we haven't given an order and we're not moving. Sorry, I'm not explaining that very well. Basically, if we only checked for this, we could have asked for a path, and if it was a particularly long path, it would have said it would have kept calling it until we'd found the path, and that'd just be not good, waste resources, overload the system, and just generally be bad because we only need to call it once. So we need to check for waiting for the path to be is false as well. That's done in the control action. We made the unit movement a global variable here, just so we don't need to get it every time. And we're checking that are we moving is true, so we don't need to check that we have got a path, because if we're waiting for a path, we don't need to check if we're waiting for a path here, because we're checking for it being true, so it's only set to true once we have a path, so that's fine. If we're not moving, however, so if we're, say, waiting for a path, so are we moving isn't true, we'll just return false, the same. We're not done with this action yet. Gather resources, I believe, doesn't use it. I don't remember changing it here. No. Nope. Doesn't use it. Build building, does that use it? Nope. Action attack unit doesn't. Okay. So that is pretty much it for today. Again, we'll just do a quick demo. So it's not so much of a thing you can see. This time it's not like a new feature or anything. You just got to trust me that it has been optimized. So again, you can see that we've made a new system that drastically decreases the number of nodes by over 50%, which may be more or less depending on how you choose to generate grids. And we've also added code basically to implement threading with our pathfinding, so that if we are calculating a particularly long path, it won't hold up the main thread, and it will just do it on a separate one, so the game doesn't freeze while we calculate that path, which is good. So I'll see here, and I right click here, it will wait for the path, as you can see here in the debug log, but we can still move, so it's calculating the path for this archer, and once it's done, I mean, it will still take a while because it's calculating a path through God knows how many nodes. Well, actually, some like 20,000 odd. So if we just wait a while, see, now it's got the path. The archer has started moving, and you can see the frame rate's alright, about 35, 40 FPS because I've got stuff running in the background. And you can look at the little bastard go. So he is going to run all the way to the other side of the map, which is about where the camera is, there-ish. We'll just watch him there. So yeah, so recap: threaded pathfinding and node optimization. So cheers for watching. Like, comment, subscribe, all that shit. Go check out Loud or Quiet, which is on HBO. All the links will be in the description. What else? Yeah, Make Station was pretty much done, so I'll go check that as well. I'll leave a video to quite useful video by Quill18, who did something on threading and go routines and stuff, which I found quite useful, so maybe you will too. That'll be linked there. The original code I modified for the actual implementation of the threading will also be in the description, so you can go check it out yourself. Just pay homage to the source, and yeah. Cheers for watching, and goodbye.